Okay, now let's discuss about the new section, which is double hashing. So what is double hashing? The word double, the word double, it means two. So double means two. So double hashing use a secondary hash function. So second means two. This is the second one. We have first and second. The secondary hash function, we call it DK. And it is to handle the collision by placing an item in the first available cells of series. Okay, so we will take a look later with example. Now the equation will be like this one. I plus j, where j is a number from 0 until n minus 1, and we have dk. So dk is another function for finding the first available cell. And we have another modulus, mod n. So the secondary hash function dk cannot have zero values. So dk here is the function. It cannot be zero. Okay, so it should not be zero. And the table size n must be a prime. So you know prime. Prime means forgot the Korean. This is a number that can be divided by one and its own number. So this is to allow probing of all cells. So we want to find what are the proper cells for this double hashing. So the common choice of compression function for the secondary hash function. So tk, yeah, this is the secondary hash function. We can use q minus k mod q. So q is a number which is less than n. And q is a prime. So prime means any number like 2 or 3, 5, 7, 11, 13, 17, 19, and so on. So the possible values for D to A, so this one. So the possible value should be starting from 1 until Q. So let's suppose Q equals to 7. And the possible value would be 1, 2, 3, 4, 5, 6, 7. Okay. If the Q is 11, then it will be 1 until 11. Okay. So we need to avoid 0. That should be go 0. Now, how can we handle the collision with double hashing? To consider the hash table storing integer keys that handles collision with double hashing. So we have k. So the k is the number that we use on the previous example. We have 18, 41, 22, 44, 59, 32, 31, and 73. Now we have our hash table. So this is the table. We are going to use the hash table to store this value. So how to save this value into this table? Now we have n. N equals to 13. What does it mean? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, we have 13 space. And then we have its k. So this is the first hash function. The first hash function, we want to use k mod 13. If there is a collision, okay, if there is a collision, then we will use decay. So this is the second hash function. So let's try to insert a key 18, 41, 22, 44, 59, 32, 31, and 73. Now, let's check. If I have the k equals to 18, so 18 mod 30. The result is 5. Now let's check 5. Okay, 5 is empty. Then we put into 5, or we call it the proofs is 5. What about the decay? Okay, we can calculate the decay, but we will do this as the priority. So this is the priority. If no collision, then we will put in the 5. If it is collided, if there is a collision, then we will consider the, if there is a collision, we will consider this one. Okay. So if there is a collision, we consider the second function. Okay. Now let's check the second value, which is 41. 41 mod 13. What is it? This is 2. Now let's check. 2. Is it empty? So this is 18. 2 is empty? Yes, it is empty. So I put 41. Now next go to 22. 22 mod 13. It is 9. So let's check 9. It is empty. So we put 22. 44. 44 mod 13. It is 5. Okay. So let's see. Okay, 5. We have a value here. And if you use the linear probing, you still remember? On Monday, we learned linear probing. So for the linear probing, if it is not empty, we go to the next. We go to the next empty cell. But for the double edging, we need to check the second function. What is the second function? The second function is the result is 5. So how to get 5? So we use this function. 7 minus 44 mod 7. What is the result? 7 minus 44 mod 7. 7. So it is 7 minus 2. Because 44 mod 7 is 5. Sorry, 7, 44 mod 7 is 2. Then 7 minus 2 is 5. So the decay equals to 5. But what about 5? 5 and 5. So it's the same. So we cannot put the value in the index 5 because 5 already have the value. So we use the J. If you still remember the J, J. What does it mean by J? So J is the factor from 0, 1, and so on until n minus 1. Okay. So it is I plus J dk. So if we say that I is somehow a number, or maybe let's put it as 0. Okay. So if it is 0, then we can have decay I plus J decay mod n. So it means we want to get the J at the first time. When we get this proof is 5, it is not possible. So let's move J into 2. Okay, so this is when J equals to 1, we have 5. And let's move J when it equals to 2. When it is equal to 2, so we want to multiply the decay, which is 5, with 2. And then we will do with the I, let's say I start from 0. So 0 plus 2 multiplied by 5 mod n. So it means 10 mod 30. So 10 mod 13, then we will get this is 10. Now let's check. So in the previous one, we have 18 here, we have 41 here, we have 22 here. So let's check about the position 10. Okay, 10, it is still empty. So we put 44. Now let's check another value, which is 59. So 59 mod 13. 59 mod 13 is 7. So let's check. 7, it is empty. Then we put here 59. We don't need to consider this one because there is no collision. Now let's move to 32. 32 mod 13. It is 6. So 6, it is empty. Then we put 32. Now let's move to the 31. 31. The XK, so it means 31 mod 13, it is 5. 5, we have a value which is 80. And okay, we need to consider the decay. So the decay is 7 minus K mod 7. And it is 7. K is 31 mod 7. And 7 minus 31 mod 7. It is 3. So the result is 4. Then 4 will be 8. Okay. So we have 4 and we need to check the proofs. Okay. So the proofs, we will use the function I plus j multiplied by the decay mod n. So let's suppose the I we have 0. Okay, so we start with 1. multiply by the decay for mode n. So we have the for mode n for mode 13. For mode 13, so we have the value I. So we have the I plus j decay mode n. Then what is j? J, if it is 1, then we have the decay is 4 mode n. So for the value of I, yeah, we can put the hk or we can put the 0. Okay. So let's suppose if we put the hk. So if it is 5, okay, 5 plus 4, 5 plus 1 multiplied by 4 mod 30. And we have 9 mod 13. Okay. So in the case, we have 9. So actually the I, you can put any number like 0 or which is the hk. Now let's suppose I have this one as 5 and then I put this one 5 plus 4 which is 9 mod 13, then we will get this is 9. Now let's check 9. 9 we have the previous one, we have 18 here, we have 41 here, we have 22 here, we have 44 at the position 10, we have 59 at the position 9, we have 32 at the position here. So 9 already available. So we cannot put here. Then we will have 5 plus jdk mod n. Then it means we can have, because j when it equals to 1, the result is 9. When j equals to 2, okay, so we can have 5 plus 2 multiplied by 4 mod n. So 5 plus 8. What is 5 plus 8? It is 13. 13 mod 13. It is 0. So we have 0. So we can put 31 in the index 0 if it is already collision with other value. So the index 0, it is empty. Then we put 31 here. Next, we have 72. 73, it is also, we try to do the mode 13. So the result is 8. And let's check. Okay, 8 is empty. Then we put 73 here. Okay. So we need to put every value here without any collision. So in the worst case, we will have always 3 functions: search, insertion, removal. Search means, yes, concept. We have only 3 functions for every of the ADP: search, insertion, sometimes we call it deletion or removal. And all of them will give you the ON time. So the worst case occurs when all the keys inserted into the map collide. So the worst case means if there is a collision, then yeah, we will do the process. So the worst case we will do until n time. There will be another factor, we call it load factor. So the load factor is using the alpha. Alpha means the n divided by big N. So it will affect the performance of the hash table. Assuming that the hash values are like random values, okay, so it can be shown that the expected number of fruit of an insertion with opening address is 1 divided by 1 minus alpha. So this is just to say the approximation. We call it, this is the approximation. That's why we call it, this is the load factor. So the expected running time of all the dictionary ADT operation in hash table is O1. So if there is no collision, we call it the best time is O1. Okay, as you know here, the best time. Okay. If everything is fine, then O1. In practice, hashing is very fast provided the load factor is not close to 100%, which is 1. Okay. So how many times that you do with the second hash function, it will not reach the end. So for example, if you have 8 numbers, you will not reach until 8 numbers. If you have 13 numbers, you will not reach 13 numbers. So it will be less than 13. It will be less than n. So that's why the load factor is not even close to 100%. So there are many applications for the test table. So if you are using the small database, or if you are using the compilers in your programming, or if you are using something like browser and it catch the browsers, then yeah, most of them they use the test table. So I think I put one more file. So I put the test table summary for you to look at. So at least we learn 3 things for the collision. The first is separate chaining. Okay. So here is the overview. So in the separate chaining, we have this table. So we call this is the table, and then this is the value, or the integer value that you want to put into the table. So the problem is how to insert this value into this table. So if you run this one, I created the simulation, so you can take this material in the e-class. So if we have the mode 13, so 44 mode 13 is 2, so we put into 2. 5, so we put in the index 5. 28 mode 13 is 2, so we create a list in the index 2. 36 mode 13 is 10, so we have a new value in this index. 25 mode 13 is 12, so we put value here. 41 mode 13 is 2, so yeah, there will be a list over here. 38 mode 13 is 12, so we create another value here, and this is a linked list. 10 mode 13 is 10, so we create a list. 12 mode 13, so we have another value here, so we can consider this is another list. 90 mode 13, it is 12, so yeah, this is the list for the index 12. So we call this is separate chain. Each of the index will have a new chain. Each of the index will have a new chain when it is collided, or when there is collision, there will be a new chain. Okay. So this is the chain. For the linear probing, we have the number 18, 41, 22, 44, 59, 32, 31, and 73. So with the function mod 13, okay, with the function mod 13 means 18 mod 13 is 5. So we put into the 5. 41 mod 13, it is 2. So we put 41 into index 2. 22 mod 13, it is 9. So we put into the index 9. 44 mod 13 is 5. But in the index 5, we have already value. Then we can go to the next empty cell. So this is the linear probing. Next, 59. 59 mod 13 is 7. So we just put in the 7. 32 mod 6, 13, it is 6. But 6, we have already an element. Then we need to go to the next condition. Then because 7, we have already a value, so we put it is in the cell index 8. 31, okay, mod 13, this is 5. Because 5 already available, so we go to the next empty. It is already available, we go to the next. We go to the next, we go to the next. Okay, this is empty. Then we will put the 31. Okay, because all is not empty, so we put into the index. 73. 73 mod 13, it is 8. But it already has an element. Then we go to 9, it is still not available. 10 is not available, then we put 73 into the index 11. Okay. So this is how to insert the integer value with the linear probing. So the double hashing, the one that we just learned before, we have HK and we have DK. So HK means the first hash function and DK is the second hash function. So for the 18 mod 13, it is 5. And then this is 7 minus 4. So the probe is 5. You can put in the index 5 because index 5 is empty. 41 mod 13, it is 2. And then the decay is 7 minus 6, which is 1. Then we just put into the index 2 because this should be 2. Okay, this should be 2, not 1. 22 mod 13, it is 9. And the decay is 6. Because 9 is still empty, then we put into the index 9. 44 mod 13, it is 5. Okay, 5 already has value. And when we use the decay, we also have 5. Then what should we do? So in this case, okay, I'm using I equals to 5. I equals to 5, it is this number. Okay. 5 plus 1 multiplied by 5, which is 10 mod 13. Then we have 10. So 10, it is still empty, so we put 44 into the index. 10. 59 mod 13 is 7. And the decay is 4. Because 7 is still empty, so we put 59 in the index 7. 32 mod 13, it is 6. So 6 is empty, so we put 32 in the index 6. 31 mod 30. Here is 5. So 5, we have a value. So we need to consider the decay. So the decay here is, so let's use the I equals to 5, and then let's put j equals to 1. So 5 plus 4, what 13? It is 9. But 9, we have a value here. So we have j equals to 2. So when j equals to 2, so we have 5 plus 8. This is 13. 13, mod 13, it is 0. And we put the value 31 in the index 0. And the last is 73. 73 mod 13, it is 8. Because 8 is empty, so we just put the 73 into the index. Okay. Okay, so that's the three things for the collision handling. So you need to review this one. Maybe in the final exam, there will be one problem about this one. Okay, so the time is a little bit. Okay, let's have a break. Okay, let's have a break for 10 minutes. I will continue after that.